Hello everyone. Today we are going to discuss about keras, a very high level neural network API for deep learning related models and tasks. It is written in Python and initially released in 2015. Okay. Keras using TensorFlow as backend. So TensorFlow is also an open source machine learning library developed by Google. It serves some powerful computational engine for executing machine learning models, and it also supports both CPUs and GPUs. As we know, deep learning libraries mostly need GPUs for parallel computational programming, because we are going to deal with few of the high dimensional data like pictures, videos and text embeddings. For this we need GPUs, and through keras also you can use GPUs to compute your data. The key features about keras are it is very easy to use, the API is accessible for beginners while maintaining flexibility for advanced users. It is also compatible with various neural network architectures like feed-forward neural networks, RNNs, CNNs, and it is providing us the GPU support to do the required calculation. Few of the prerequisites that you need to have before jumping into the code part of keras. We should have some basic Python programming skills, mathematics and statistics about linear algebra, like how matrix calculation done, vectors, dot products. Okay, basic calculus like derivatives, partial derivatives, etc. Few machine learning concepts also we need to before we deep dive into keras code part, that is our supervised learning. We should know what is the supervised learning, how this classification done using supervised learning, what is a neural network, what is the concept of neurons, activation functions, feed forward propagation. So these are some basic things you need to understand. How training done in a machine learning scope, how data splitting done, how we divide the training and testing data. So these basic knowledge we should have before jumping into keras. Now I assume you guys have the knowledge about these topics. So let's deep dive into keras. First of all, how to use keras. This official doc website will lead you to the required documentation of keras. But as of now, we can use these commands to install keras and TensorFlow. Pip commands, pip install keras and pip install TensorFlow. And as soon as we do that, you can check the versions of keras and TensorFlow by running this piece of code in front of my screen that you are seeing. Okay, to know the version of keras and TensorFlow. Now let's deep dive into the code part. We are going to create a small model using keras, which is going to solve one of the famous problem to identify the handwritten digit. So we are going to create a small model whose input will be an image. The image will be a handwritten number, and at last our model should detect that number. So this is basically a multi-class 10 class classification problem where the input data will be an image, and from that image you have to identify what is the number written in that image. Okay, and these are few of the functions and libraries that we are going to use while creating this model. As we know, we have to have the understanding of what is a dense layer, flatten layer. So these sequential, dense and flatten, these things you are going to need to construct the model. Keras API is also providing the dataset called MNIST. This is the dataset that we are going to use. This is basically the images of handwritten digits. And from the callback section of keras, we are going to use TensorBoard, which is going to help us to analyze our model performance in terms of accuracy and loss, date and time to capture the relative date while when we are running this model. Coming back to the data splitting, this is how we split the data with xtrain and xtest, ytrain and ytest. And in the next step, we are doing the pre-processing. I will run this code while explaining this code to you, so that we'll see what is the result. And here you can see your model started training on the epochs. Number of epochs, we have chose 5 epochs. Let's go back to the code part that we are discussing. This is where you do the normalization of your data by dividing the maximum pixel value, that is 255, to your both train and test data. Then we are going to construct the model like this, where we are going to use this sequential function that we imported and flatten layer, then one dense layer. This is a fully connected layer neural network, and we are going to use 128 neurons for this. And finally the output layer, which is having an activation function called softmax. Softmax is used to classify at your output what is the probability of each class. Suppose we are here classifying 10 classes, so the softmax function will help us to identify which class is having the highest probability. And in the middle layer, we are using ReLU, that is rectified linear unit activation function, just to introduce some non-linearity to our data. In this piece of code that I selected, this is where we are using compile function. Inside this function, you have to provide few of the parameters, like what is the optimizer that you are using. So I hope you understand what is an Adam optimizer. The loss function, here we are using a classification problem, so that will be a categorical cross entropy loss. And the metrics we are going to keep an eye on is the accuracy and mean absolute error. Okay, this is how you need to define or construct your model with the required parameters. Where this keras.utils.plot model function will help you to save your model architecture in the form of an image. You can see I have saved this model plot.png. If you double click on it, you will get the idea about your model architecture, as we are building a small model. So this is very simple here. Here you need to understand our input is going to be a picture with 28 cross 28 dimension. And this input we are going to pass to a flatten layer, where it will flatten this 2-dimensional data to one 1-dimensional array, that is 784. Then once the data is flattened, then we are going to pass this flattened data to the dense layer, that is with 128 neurons. And now the output of this layer is having 128 dimensional data. The output we are going to feed to our final layer, that is our softmax layer, with which is having 10 number of neurons, which will tell us the class prediction. Okay, so that means in this layer we'll get the output. Okay, and this piece of code written here is to capture the analysis while training the model in terms of loss and accuracy. So this piece of code will capture the logs about your training data or the performance of your model. Then as usual, we know how to train a machine learning model by calling the fit method, providing the training data. Here number of epochs is also one of the hyperparameter that we can use. Validation data is already X test and Y test. And the callback we are using here as TensorBoard callback, which we defined here. Finally, we are printing the result, test loss and train loss, test accuracy, etc. And here you can see the test loss, test accuracy, and test absolute error. Okay, with 5 epochs, just to showcase how we can use keras. And once the training is done, you can run this piece of code to visualize the performance of your model. Here I am using a Google Colab notebook, so this first line specific for Google Colab only, and this second line will launch the TensorBoard analysis inside your Jupyter environment, and you can cross verify, or you can see the performance with respect to each epoch through this analysis report. You can also see epoch loss, like epoch wise loss. You can see the first epoch, what is the loss, and how this loss gradually decreased to a certain level with respect to each epoch. Same you can do for accuracy as well. You can see accuracy values and accuracies with respect to the errors, how the accuracy getting increased with respect to each epoch. That part also we can explore. So this is how we are going to use keras to solve few of the non-linear tasks like image detections, large language models tasks. Also, you can utilize this concept and models from keras. Thank you so much.